Hello everyone, welcome to my YouTube channel. In this video, we will be discussing about the kurtosis, one of the significant topic in statistics. We have already discussed about the outliers in our previous videos. We have also seen how to handle them. We have noticed that some distribution have sharp peaks while others appears flat, and some of them follow the normal distribution. Well, what does the kurtosis has the relationship with them? We will answer in this tutorial. In this video, we will be talking about the kurtosis in very much detail. So let's start our discussion. So kurtosis is basically one of the statistical measure which describes the shape of the probability distribution. It measures the tail endness of the distribution. Larger kurtosis means heavy tail, which means the presence of outliers. The formula for kurtosis is summation inside the bracket of x minus mu raised to the power 4 divided by standard deviation raised to the power 4. So here basically the x represents the data point and mu represents the mean. So we take the difference of them, which is raised to the power 4, and we add it for all the data points, and then we divide it by the standard deviation, which is raised to the power 4. So that particular value is going to give us kurtosis. So please remember the formula of kurtosis. And there are two things here, kurtosis, and then we have the excessive kurtosis. So we are going to discuss about the excessive kurtosis in our next PPT. So so to understand what is excessive kurtosis, here we are going to talk about what are the different types of kurtosis and what is excessive kurtosis. So excessive kurtosis is nothing which is equal to kurtosis minus 3. So whatever value which we got from kurtosis, the formula which I showed you in the previous slide, minus 3. So that is going to give you the excessive kurtosis. So here when it comes to types of kurtosis, there are three types of kurtosis. One is the mesokurtic, which is basically the normal distribution. Then we have the leptokurtic. Then we have the platykurtic. So in the case of mesokurtic, which is a basically normal distribution, the excessive kurtosis value is near zero. So which means the kurtosis value is 3. So excessive kurtosis value will be equal to 3 minus 3, which is equal to 0. So it follows the normal distribution, which means that it has outliers, but very less number of outliers. So it has not that much extreme outliers. Okay. So and for example, you can take the height of the people of a country, the IQ score of the human beings. So all those kind of a data which follows a normal distribution can be a part of the mesocutic. Then we have second the leptocutic. So leptocutic, what happens here is like it has a when you look at the example of leptocutic, which is basically the blue one, the blue line. So this is a kind of a leptocutic distribution. So here in the case of leptocutic, you can see it has a sharp peaks and very broad, very heavier tail. You can see here it says a heavier tail and sharp peaks, which shows that it has more extreme outliers than the normal distribution or than the mesocutic. So it has the value of leptocutic is positive. Excessive kurtosis is positive, which means the kurtosis minus 3 will be greater than 0, which is equal to kurtosis greater than 3. So in this case, for example, we can think about a data which has a lot of outliers, for example, or which is a very kind of a volatile data, which has extreme values. So a stock market can be an example. Financial risk data can be an example. Then we can also think about the weather data. Sometimes it has a extreme weather, so then the temperature fluctuates also. So that can be a given can be considered as an example of leptocutic. Then we have the platycutic. So platycutic is basically the diagram in the green color. So it shows the lighter tails and flatter peaks. You can see here the peaks is much more flatter, or we can say broader. So it has very few extreme values, fewer than the normal distribution. So it has a negative excess kurtosis value, which means the kurtosis minus 3 will be less than 0, or the value of the kurtosis will be less than 3. So in that case, this is about the plateaukurtic distribution is basically talking about uh, more kind of a uniform distribution, the data which is more stable. You can say the score of the students, which doesn't changes much over a period of time. So yeah, so these are the three types of kurtosis. Now let's look at some examples. So real world examples and practical application where the kurtosis plays an important role is one is the stock market or the finance risk assessment, where high kurtosis means more extreme price fluctuations. We all know that the stock market or stock returns do not follow a perfect normal distribution. They can have large spikes, which can depict a sharp gain or crashes. So this basically these type of data follow the leptocritic kind of a distribution. We can also think about the 2008 financial crisis, where extreme losses were observed more frequently than expected in normal distribution. Then we can think also about the weather, where we have where sometimes we have extreme temperatures or extreme cold waves, so or extreme heat waves. So in that case, it gives us a high kurtosis value. So then this kind of situation helps the climate scientist and meteorologists to predict and model extreme weather risks which can happen, and which in turn helps also the insurance company to predict the rare but impactful climate disaster so that they can prepare the things in beforehand. Um, the other example in signal processing, so we know that signals contains a lot of white noise. White noise is basically disturbance. So we the people who are working in the signal processing, they always want signals with the low kurtosis, so that they have a lot of they have a minimum outliers and smooth variation. So the people who are working in the white noise signals, basically when they are building a communication system, the intensity of signal variations, they make sure that it is evenly spread instead of having extreme peaks. So using this kurtosis-based filtering technique, the engineers, they remove the spikes or outliers from the noisy signals. So it also it helps us in very much in the speech recognition, noise reduction, and also enhances the radar signal processing. So yeah, and then if we talk about from the data science and statistical perspective, so it helps us in understanding the data. We know the shape of the distribution, and with the help of the kurtosis, we can know the presence of outliers, or we can understand that whether the data is uniformly distributed or it has an extreme values. Um, and then based upon the presence of outliers, we can provide or apply the statistical measure. We can think about how to handle those outliers using a simple central technique, central tendency technique, or we can also do some kind of a transformation using the logs square root. So basically it helps us in understanding the data and make the necessary measures. Then when we talk about machine learning, so we know that in machine learning, if we feed the wrong data, the prediction will be also not accurate. So when we know that there are outliers, which is being depicted by high kurtosis, we can we can handle those kind of data and do a more kind of a improve the feature selection with handling the extreme values. For example, if you talk about the fraud detection, if our transactions always contains very high kurtosis, which means that it suggests the fraudulent activities, but we can't put that data into the training an ML model, because sometimes if we put a lot of outliers in our machine learning model, it can cause bias, or because of the too much focus on the outliers. So we need to ensure a better normalization for the data. So that's why this with the help of kurtosis, it helps us in understanding that, and then we can follow a better feature scaling technique, or better feature scaling technique before feeding the data into the models. Also, when it comes to risk assessment, we saw that high kurtosis means higher probability or extreme events. So, like sometimes if we, it helps us in making a decision for portfolios in the case of risk management. If we are working for a kind of a credit score company, so it can help us in finding out the credit score and actuarial signs. So yeah, so these are the importance of kurtosis in data science and statistical analysis. And one of the most common key takeaways and implications of kurtosis is that it helps us in understanding the data. It helps us in improving the model, and then it provides a better insights, and we take more better decisions. So please let me know if you have any questions in the comment section. And thanks for watching this video.